In this video, we will explore a particular Wi-Fi module, namely the AMW004 from Zentri, which was recently acquired by Silicon Labs. There are many Wi-Fi modules on the market. Probably the most popular right now is the ESP8266 due to a large user community and the fact that it is extremely cheap. It is probably the quickest way to get your project connected to the internet. Now, there is another module that is quickly gaining popularity, which is the ESP32. It is not as developed as the ESP8266 yet, but it again packs a load of functionality for a very low price. The nice thing about the AMW004, however, is its robust functionality and overall ease of use. It is more expensive than the ESP modules, but I believe it's worth it. I should also mention that there are many more Wi-Fi modules in the market, but all the other ones that I have tried have been much more difficult to use. So this is the actual module, and it would have to be soldered into an application, but when you're first starting to develop, you would probably use a development board such as this one where the module is already in here and the pins are broken out with some user buttons and such, or maybe your own breakout board. But once you've actually done this and you've embedded this into your system, you still have to be able to somehow use it, and usually you're going to interface it with a microcontroller which is going to issue commands to it, and so you have to know how this module is going to respond to those commands and how to actually make the best use of it, and that's what I'm going to show you. So I'm assuming that you've already made your application with a development board or a breakout board, and now this is part of an embedded application, and I would recommend that you still leave some kind of a serial interface available to this through UART in order to be able to quickly change it and debug it if necessary. So the first thing that you want to do is actually get this connected to the internet. Now I'm going to assume that you are already connected to the serial interface using something like this, where it connects from the USB to the UART interface using these 4 wires, and you're able to talk to a device using a terminal emulator. So for Windows, you would use something like Terraterm, and when you first open it up, you're going to get something like this, and I'm going to say I want a serial connection, and your device will show up as a COM port, and so you might have several, but you have to find the one that you have that is actually being used for the AMW004, and say you're going to connect to it, and by default it's actually going to be not at 9600 baud, but actually at 115,200, and so you would go to the serial port properties and change that to this, and now you're ready to communicate with it. The first kind of check you can do is just to type in VER to get the version number, and that's going to return something if you have successfully communicated with the device. So now we want to connect it to the internet. Now there's a very nice utility that we can use, and that's going to be a browser-based utility. However, you can directly connect this to an SSID and password using some other commands, but I just want to show the web utility because it is just so handy. So I will say setup web to initiate that, and now the module is going to start acting as an access point with its own SSID shown right here, and I'm going to connect to that from my computer. So if I look at my Wi-Fi utility here, I can see that this is actually now showing up as an access point, and I'm going to say connect. And so now it connects, and that's reflected also in the terminal right here. It's connected, but this actually has no access to the actual internet, and your computer will probably warn you about that. In fact, I had to actually unplug my Ethernet cable in order to remain connected to this, as opposed to the computer choosing the Ethernet network, which actually has an internet connection. You'll see a similar kind of thing if you try this from an iPhone or from an Android device, where you have to explicitly tell it to remain on this network. But once you're on the network, you can actually open up a tab in your browser and say setup.com, and that's going to take you to this utility for Zentri. And this will show you all the access points that are available around you, and I'll choose one, and then I'll type in my password. And you also want to check reconnect to device and say connect. Once you've done that, it'll take you to a screen like this, where it's going to redirect you to the interface for actually managing your chip. Now, if you were doing this from an Android, it wouldn't automatically take you here. You would have to actually get here either using another app, which is a Zentri Discovery app, or you would have to just type in your IP address of the device manually. Now, of course, you wouldn't know the IP address right away after the association is made, but if you go to the terminal, it will actually tell you that the IP address is this after the association is complete, or you can always query it as a variable by typing in get WLNI, and that's going to tell you your IP address. And there's this right here. So if you want to then do this manually, you can copy this over, go to a browser, and I'll close this tab just to show you, and just type in that IP address from a browser, and it's going to take you to this management utility. Now, before I get into what we can do from here, I want to point out how to perform an over-the-air update and how to claim your device. So first of all, you want to create an account with the device management service from Zentri here for the DMS, and you'll just fill in your information and you're going to get an account, and then it will take you to a screen such as this where it shows you the devices that are associated. So I already have several, but you're not going to have any until you actually claim one of these devices. And to claim it, you will go back to your terminal and type in DMS claim followed by your username here and password for the DMS. So username space password. And it'll claim your device and then make it associated. And once you've claimed it, you can perform things like over-the-air updates just by typing in OTA and hitting enter. So then you can check your version again and make sure that is the latest one, and you're good to go. Now, for the web interface that we have right here, this is actually extremely handy, and this is what really makes this, to me, distinct from other Wi-Fi module offerings. First of all, you can manage the file system very easily just by going to Files, and you can actually drag and drop files right into here, and they're going to be added to the file system. So you can design a website if this thing is acting like a server or anything else very easily just by dragging and dropping files into here and inspecting them, deleting them, and other such file management things that are much more difficult with other modules. The other really nice thing is you can look at this console, which is actually just a remote terminal. So you can actually then not use the serial connection to your chip. And once this is out in the field, you can still send it commands, for example, checking the version or any of the other things that we've done using this remote terminal right here instead of using the terminal emulator like TerraTerm. Further, you can actually check out a lot of other things like the firmware, which you can update from here, and other things about the system just from this interface right here. Now, to actually interact with the module, you're going to use commands and variables, which are going to be documented in the command API. For variables, you're going to use the get and set commands in order to affect them, and we already saw this when we typed in get WLNI to get the IP address. We got the variable WLNI, which by the way is an abbreviation. So if I go to variables, every variable is going to have an abbreviation. I can go to the WLAN interface and WLAN.network.IP, and if I go into this command right here, I can type in get WLAN.network.IP, and that will give me that. But you can also see there is also an abbreviation for it, which is shown right here, get WLNI, so just a shorthand for doing this same exact thing. And so that was getting this IP address. We used the get command. For other things, we can actually set them, followed by a save and a reboot command in order to actually make the change permanent. So for example, something that's going to be very useful with our embedded application is going to be the baud rate that we're using. 115,200 is just the default, but we can change it to something else if that's what our microcontroller or system requires. And so we can find that variable, and there's a very long list of variables, of course, under UART, UART.baud, and we can actually see that right here. If I say get UART.baud, and I also have to specify which UART I'm using. So there are two UARTs available on the AMW004. I'm using the first one, so I'll say get UART.baud1, and it gives me 115,200. I can change this to something else by saying set UART.baud1, and then maybe a different value like 9600. Now I'm not going to do this here because then I would have to restart TerraTerm because I would have changed the communication rate, but just to show you what you can do. And you can see the list of possible baud rates right here that you can actually set this to. Also very useful for microcontroller applications is going to be flow control. So I'll go to that documentation right here, and that's going to be to use the RTS and CTS pins in order to make the communication more reliable. So I can also type in get UART.flow1, and it's going to tell me that it's currently on. So this I can set this UART.flow1 off, and it's going to say set OK if everything comes back OK. However, this change is actually not affected until I also say save and reboot. And once I reboot, the whole system starts back up again. It's going to reassociate with the network because I told it to reconnect automatically when I set it up in the web interface. And now if I say get UART.flow1, it's going to be off. And so let me set that back, save, and reboot. Some other very useful variables for microcontroller applications are going to be GPIOs that get activated when a condition is true. So for example, if I go back in the WLAN interface and I look at the network status GPIO, this is actually going to be used to indicate when there is a network available and when there isn't. So this is very useful for a low power application, for example, that you only want to do something when a network is available and not bother if it's not. So you can put the microcontroller to sleep, put the whole system to sleep. And so you can use this GPIO, and it's going to be asserted high when there is a network and low when there isn't. And so you would do this in the same exact way. You would say set, or rather I'll show you first what I already have it as, get WLNO, and it says it's 3, so that is the third GPIO pin of this Wi-Fi chip. And so I can set it to another GPIO if that's what I want to use instead. And so then this is wired to my microcontroller, and my microcontroller is looking for the value of that. Another useful one here is going to be in the system command GPIO, which is going to be asserted high after the system in the Wi-Fi chip responds to a command. So if I issue a command from a microcontroller and I want to know when that command has been processed and we actually get a response, for example, like the set OK response when we change a variable, so that the microcontroller can issue the next command, this is going to be very useful because once again it can make things interrupt based, and so then my microcontroller can just wait in a low power state for that to happen and not do anything before that changes. And so I can see, for me, I have it get SYCG, and right now I have it on GPIO 4, and again you can change it to anything that you want. One more variable that's very useful for microcontroller applications that I want to mention, and there are many, by the way. As you can see, there are very many variables that you can play around with and look at on your own, but one more that's particularly useful is the command echo. And specifically what that is, as you can see right now, whenever I type anything, it actually gets echoed back to me. But if you're using a microcontroller, this is undesirable, because if you're using a microcontroller, you don't want every single character to be transmitted back to it, because that's just going to flood its UART buffer and not actually be useful. You only want responses from the Wi-Fi chip, not the echo of every single command. And so you can turn the echo off when you're actually using this with a microcontroller as a setup. And so that's another system variable here. You can see get SYCE, and right now it's a 1, it's active, it's true, and you can turn that off and then things aren't going to be echoed. So it's useful for the echo to be on when you're a human who is debugging this, but when you're actually putting this into a deployed application, you don't want the echo to be on because it's just going to be distracting to the microcontroller. Now as far as commands, as opposed to variables, these are going to be like functions which we're going to execute by typing them along with possibly some arguments. So we've actually already seen several. For example, DMS claim was one, OTA is another which performs the update, set and get are commands, save and reboot are commands, and there are many more which you can explore by clicking on the commands right here, and you can see many such commands. So for example, in my applications I've used the file create command, which is going to make it easy to create a file in the file system, besides just dragging and dropping. If you want a microcontroller to make a file as opposed to just dragging and dropping when you're managing things, you can set the level of GPIOs by using commands like GPIO set, GPIO dir, in order to change its direction from input to output, and other such things. There are sleep commands in order to make this into a lower power application. You can list available streams in order to act on the ones that are actually open. So for example, in the WebSockets application, you may want to list the streams that are actually connected to your server if your Wi-Fi chip is acting as a server, and only send information to them individually instead of just to everywhere. And if there are no streams connected, to again just go to sleep, for example. And there's commands like write to actually write to a stream, and version to check the version of the firmware, which we've already done. And there are many commands, and for the most part you're probably not just going to look through these commands, but rather you would probably look through application examples that we have right here and explore them and find the commands that are used in them, find applications that are similar to ones that you want to create, and then take code from them in order to make your application work, and look up variables and commands as you need to as you're creating your code. Altogether, we have explored the AMW004 module a little and have seen some of the functionality that makes this a very user-friendly device. There is a ton more functionality that can be viewed on their website. Furthermore, the module itself has the capability to be used as a standalone system, as it contains a microcontroller itself, even though for my projects I have used it as a slave device to another microcontroller. With this introduction, you should have the tools necessary to get your own project underway.